Welcome to Hartman Math. It's unit circle day. Before we get to that, a little warm up, a little reminders about degree and radian measure of angles. So our angle theta is 2 pi over 9. Find the following: positive coterminal, negative coterminal, complement, supplement, and then go ahead at the end, convert theta into degrees. Go ahead and pause here and work through the warm-up problems. To get a positive coterminal, we could try adding 2 pi, and we would get 20 pi over 9. To get negative coterminal, we could try subtracting 2 pi, and that worked. It may not always work. If it's still positive, just subtract 2 pi again until you get it to be negative or whatever it is that you're desiring. As far as the complement, remember complement has to add up to be pi over 2, so if we go pi over 2 minus our angle, we'll get 5 pi over 18. The supplement adds to be pi, so pi minus our angle, 7 pi over 9. And converting to degrees, we need to multiply by 180 degrees over pi radians, so 2 pi over 9 times 180 degrees over pi. Pi's cancel. 180 divided by 9 is 20 times the 2, 40 degrees. Needs to have the degree symbol, otherwise it's not degrees. 4.2 trigonometric functions, the unit circle. So looking at a unit circle, defined to be a circle centered at the origin with a radius of 1. So our equation would be x squared plus y squared equals 1, based off of chapter 1, equations of circles, radius of 1. So some very important points on the circle: 1, 0, 0, 1, negative 1, 0, 0, negative 1. And our trigonometric functions are sine, cosecant. These are somewhat related. Cosine and secant are related. Tangent and cotangent are related. And here are the abbreviations that we're going to use. 3-letter abbreviations for each: for sine, cosecant, cosine, secant, tangent, and cotangent. So if we're looking at angles that are on the unit circle, and we know the coordinates of the point that lies on the unit circle, then if we're evaluating the sine of an angle, it will be defined to be the y-coordinate of that point. Cosecant is just the reciprocal of sine, so it's 1 over y, as long as y is not 0, because we're not allowed to divide by 0. If we were forced to, we would have an undefined value. So it is possible that cosecant is undefined. Cosine is the x-coordinate. Secant is 1 divided by x, or just flip it, the reciprocal of x. Tangent of the angle is the y-coordinate divided by the x-coordinate, the ratio. Can't divide by 0, so x is not allowed to be 0. If it was, undefined for tangent. And cotangent is x divided by y. So here's our unit circle with kind of all of our key and important angles in degrees: 30 degrees, 45, 60, 90, and so on. In radians: 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and so on. If we count by pi over 4s, which is all the exact diagonals: 1 pi over 4, 2 pi over 4, 3 pi over 4, and so on as we count around. So pi over 6, we're going long and short. So this all comes from special right triangles, 30, 60, 90 right triangles with a hypotenuse of 1. Where the short leg is half of the hypotenuse, so if this is 1, This would be, if we drew a triangle here, 1/2. And the long leg is the short leg, 1/2, times the square root of 3. So we'd get root 3 over 2. Here at 45 degrees, or pi over 4, we're talking about the 45, 45, 90 special right triangle, where the two legs are the same. And if we go leg or leg, we multiply by root 2, we get the hypotenuse. Well, if we divide by root 2, we get the leg. So 1 divided by root 2 is 1 over root 2. But if you rationalize that, you get root 2 over 2 for both coordinates. And then here at 60 degrees, or pi over 3, we're short. So there's the 1/2. And then long going up, root 3 over 2. Units, coordinate, quadrant angle, so 0, 1. And then these kind of just map across. So if you know really well the first quadrant, you can get the rest of it by just knowing where they are. Like, oh, to get 2 pi over 3, if I know about pi over 3, but know my x-coordinate is going to be negative and my y-coordinate is positive, I can take care of it. Okay. One other thing is we're thinking about signs. Should my answer be positive or negative? Because that's a very common mistake to make. You can just think about that all students take calculus. Quadrant 1, and we're talking about our 3 primary functions, sine, cosine, and tangent. All of them are positive in quadrant 1. So any angle, pi over 6, tangent's going to be positive, cosine's going to be positive, sine is going to be positive. But in quadrant 2, of those 3 primary functions, only sine is positive. So over here, sine's going to be positive, cosine will be negative, tangent will be negative. Down in quadrant 3, any angle here, for take, tangent's positive. The other 2 are not. Over here in quadrant 4, cosine is positive. The other 2 are not. So keeping this in mind, we're going to be asked for things like the exact value of the 6 trigonometric functions of 2 pi over 3. Now it's good not to have to rely on the unit circle sheet so that we can know where it is. So if we were going to kind of sketch this and come up with the coordinates, we might think like this. Well, I know pi is over here. I'm cutting it into 3 equal pieces. 1, 2, 3. So 1 piece, 1 piece, 1 piece, 1, 2, 3. And we want to go 2 of those. So here's 1 pi over 3, 2 pi over 3 puts us here. We've gone short and long. So short, negative 1/2. Long, root 3 over 2. Let's see if we can verify that by going backward for a moment. 2 pi over 3, negative 1/2, comma, positive root 3 over 2. So, what is the sine of this angle, t? It's the y-coordinate, root 3 over 2. Cosecant, all we got to do is flip it. You do not have to rationalize it. If you did, you could get an equivalent value of 2 root 3 over 3, but you are not required to rationalize the denominator. You do have to simplify, and there's one that you got to worry about that. Cosine, x-coordinate, negative 1/2. Secant, reciprocal. Tangent, y divided by x. It looks complicated. It's not complicated. Even though you would get a complex fraction by taking a fraction and dividing by a fraction, notice that the denominators are the same. They're going to cancel out. We're really just getting root 3 divided by negative 1, and that's just negative root 3. If we flip it, we get 1 over negative root 3, the negative comes out in front. Cotangent, negative 1 over root 3, or if you prefer, negative root 3 over 3 if you want it rationalized. All right, part B, our angle is now negative pi over 2. Let's think about that. Pi is over here, but we're going negative. We're going the other way, so that's also negative pi if we're rotating this way. And we want half of that. So go half that way, and that puts us right there. Straight down from the origin, unit circle, so 1 away, where radius is 1. So our coordinates are 0, negative 1. So think about it for a second. What do you think sine, cosecant, cosine, and secant, tangent, and cotangent of our angle would be given those coordinates? Sine is the y-coordinate. Cosecant is the reciprocal of that. So 1 divided by that, also negative 1. Cosine is the x-coordinate. Secant is 1 divided by that. Oh, we cannot divide by 0? That would be undefined. Tangent is y divided by x. Can't divide by 0. Cotangent is x divided by y. That one we can do. Checkpoint. Our angle is 5 pi over 4. Think about where that is, maybe sketch it. More importantly, come up with the coordinates. Use the coordinates to evaluate our 6 trigonometric functions. Pause here until you've completed it. In the third quadrant, we come up with, based on the 45, 45, 90 special right triangles, negative root 2 over 2, comma negative root 2 over 2. So the sine is negative root 2 over 2. Here's where it gets tricky. Yeah, we're going to flip that to get the reciprocal. In this case, though, we do need to simplify. So it does require rationalizing to simplify it, because you're going to see the answer is more simple than negative 2 over root 2. If we multiply top and bottom by root 2, you end up getting to just a simple, not a fraction. So that is definitely better than being a fraction, negative root 2. Similar things for cosine and secant. And then tangent, y divided by x. Hey, it's the number divided by itself. That's got to be 1. And the reciprocal of 1 is 1. So given the fact that this is a unit circle, we're given the coordinates, come up with the 6 trig functions of that angle. If you were skeptical, say, I'm not sure that is a point that's on the unit circle, you could check it out. Remember, a squared plus b squared equals c squared. If we take our coordinates, square them both, and add them together, we should get the square of the radius, which would be 1. So if we go that squared plus that squared, you do get 1. So this is on the unit circle. So think about it for a second. What do you think sine and cosecant, all of those be? Sine is the y-coordinate. Cosecant is its reciprocal. Cosine is the x-coordinate. Secant is its reciprocal. Tangent, y divided by x. Remember, the denominators are going to cancel, so we're talking about 15 divided by negative 8. Cotangent, just flip it. Definition of a periodic function. A function is periodic when there exists a positive real number that would always works such that if we go f of t plus that value, it would be the same as f of t itself, if it always works. For all t in the domain of f. And the smallest possible number c, because there could be more than one, probably would be, is considered to be the period of the function. It just means it's going to repeat itself, predictably. So example number 2, evaluating sine and cosine of the sine of 9 pi over 2. It's not really one we're real familiar with. We could count our way around and look at that. Remember, the pi over 2's are just all of the quadrant angles. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5, 6, 7, 8, 9. Takes us right back to there. So pi over 2 is coterminal with 9 pi over 2. And that means since it's in the same spot, it's going to have the same coordinates, straight up 1. And if it has the same coordinates, it's going to have the same value. So we just kind of saw that in this case, f of, we're talking about our function being sine, f of pi over 2 is going to be the same thing as f of 9 pi over 2. So what did we add? Well, you can see we could have stopped here also at 5 pi over 2. That would have the same value. It's in the same spot. It's coterminal. So that might help us with the period as well. But in terms of evaluating, if we went backwards and hit at 5 pi over 2, backwards again, since these are all coterminal angles, they're all the same, we should be pretty familiar with pi over 2. So the sine of pi over 2 is the y coordinate, and that is 1. Back in chapter 1, we discussed even and odd functions in terms of trigonometric functions, cosine and secant, as they are related, they are reciprocals. They are both even functions. If we thought back to symmetry, once we do get to graphing these, we can illustrate that then, but the graphs would be reflections of each other in the y-axis. The other four, sine, tangent, cosecant, cotangent, they're all odd functions, which means they all have point symmetry. So when we're looking at their graphs, if we rotate them halfway around, they're going to be rotations of each other, so they'll have point symmetry about the origin. So by definition then, cosine of negative t will be the cosine of positive t. So if you're asked, hey, what's the cosine of negative pi over 3? Well, that's just the same as cosine of pi over 3. So if you know cosine of pi over 3, you can get that one. Whereas over here, we're saying in an odd function, like the sine of negative pi over 3, would be the opposite of the sine of pi over 3. So we figure, okay, I get the sine of pi over 3, now just get the opposite. All right, example number 3. Now we're going to kind of use a calculator, maybe do some approximations. I think typically in the past we've been rounding to 3 decimal places, nearest thousandth, we'll see. But as it says here, you need to make a conscious decision on whether your calculator should be in degree mode or radian mode. So this first one, we're going to go tangent. It is in degrees. Now this is a little bit weird. Okay? It says 12 degrees, 30, with a little apostrophe there. So it's just another way of dividing up degrees. And this means minutes. So 1 tick mark there means minutes. If there was another number with 2 marks, then that would be seconds. It's very much like a clock. Since it is like a clock, you would think 30 minutes out of 1 o'clock, how many minutes are shown? 60. So this is saying 30 out of 60. 30 out of 60 is a half, so we can think of this, if we didn't want to try to type this all in, you just think the equivalent is just 12.5 degrees. So go ahead and type in tangent 12.5, make sure you're in degree mode, hit equals, and round it off appropriately. Whereas part B, secant of 45, got two challenges here. It doesn't have a degree symbol, so it's not in degrees. We don't need to convert it into degrees. We can just do radians on your calculator. Make sure your calculator is in radian mode. We don't have a secant button though, but we do know that secant is the reciprocal of cosine. So if we do 1 divided by cosine 45, as that is the definition, you'll get the right answer if you're in radian mode. It is not the same thing as cosine of 1 over 45. That is not the definition of secant. That's it for today. I'll see you next time.